Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the distance between 2 points in space. In the last lesson, we learned how to plot points in three-dimensional coordinate space. Today, we are going to expand on those principles. We will also be studying how to find the midpoint of a segment in space. If you are ready, we will get started. Observe this graph. You can see that P and Q are distinct points located at coordinates x1, y1, and x2, y2, respectively. Do you remember how to find the distance between these 2 points? That is correct, students. We must use distance formula we developed using the Pythagorean theorem. The distance is expressed by the square root of the sum of the squares of the difference between corresponding coordinates of the 2 points. All we must do to solve this problem is to substitute the appropriate values. Good work. Now, let us learn how to do the same thing in a coordinate space. First, let us consider a point we will call P. P is located at coordinates x, y, z from the origin point O. From point P, we will draw perpendicular line segments to the 3 planes and complete a rectangular box whose edges and x, y, and z units long. We will name the vertices O, A, B, C, D, P, Q, and R. Our resulting graph should look like this. We can see that the line OP is the hypotenuse of the right-angled triangle OBP. The Pythagorean theorem states that the square of OP is equal to the sum of the squares of OB and PB. The same principle applies to triangle OAB. The square of OB is the sum of the squares of OA and AB. We can then substitute the components of these 2 equations as we see here. OB squared becomes OA squared plus AB squared in the formula for OP p squared. The result is the formula for line OP, the square root of the sums of OA, AB, and PB. In other words, we have successfully calculated the distance between P and the origin point. Now, it is time for you to try, students. Please try to solve this problem. Find the distance from the origin to the point Q, located at coordinates -2, 0, 3. Get started right away.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I hope you did not have too much trouble solving this problem. We are trying to find the length of the line OQ. Therefore, the square of OQ is equal to the sum of the squares of the three coordinates. As the sum of the squares equal 13, then the length of line OP must be equal to the square root of 13. If that was your answer, good work, students. Now, we will learn how to calculate the midpoint of a segment in space. I am sure you remember how to calculate a midpoint on a coordinate plane. If the endpoints of a line are established by coordinates x1, y1, and x2, y2, then the midpoint is established by a bisection of the axial coordinates. This is expressed mathematically in this fashion. You will not be surprised to learn that the coordinates of a midpoint of a line segment in space can be found in very much the same way. We must take the averages of the respective coordinates of the endpoints of the given line segments. Therefore, if the coordinates of P and Q are given as we see here, the midpoint will be given by the formula x1 plus x2 over 2, y1 plus y2 over 2, and z1 plus z2 over 2. Try applying this formula for yourself, students. Given this segment defined by these two endpoints, please tell me the coordinates of the midpoint. You can start now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again. I am sure that you found the midpoint without any trouble. -1 plus 1 is 0. 3 plus 5 divided by 2 is 4. And -3 plus 7 divided by 2 is 2. The coordinates of the midpoint are 0, 4, 2. Well done, students. Let us pretend that your classroom is a rectangular box where the floor is 8 meters long and 6 meters wide. If the distance from the floor to the ceiling is 3 meters, find the diagonal distance between a corner of the room on the floor and the opposite corner on the ceiling. I think that you can solve this practical problem, students. Please try to answer this question now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Were you able to solve this problem, students? What you have learned in this lesson has given you all the tools you need. If you added the squares of the 3 dimensions and calculated their root, you found that the distance we were looking for is about 10.44 meters. Well done, students! If there is anything you do not understand about how to solve this problem, please ask teacher at the conclusion of the lesson. That is all the time we have for today. We have learned about measuring the distance between points in space and finding the midpoints of line segments. Until next time, thank you, teacher. Thank you, students.